Plain request to DigiKey. 403 every time. That's where we start. 17 million components, 3,000 manufacturers, and the front door is locked. Let's pick it. 3 libraries. Requests for HTTP. Beautiful soup for parsing, and LZ string. We'll need that last one for pagination later. Token from the scrape.do dashboard. Category URL. Fiber optic cables in this case. Page size 25, max 5 pages for the demo. And a filter state key set to 5. That number will make sense in about 90 seconds. Wrap the target URL through scrape.do with super equals true. That flag turns on premium proxies and the full anti-bot stack. TLS. Fingerprinting, header rotation, the works. Send it. 200. We're through. Open DevTools, hover over a row in the category table. Every cell has a data test ID attribute. 100 is the part number, 101 is the price, 102 is the stock. Class names change between deploys. These don't. They're tied to component logic, which makes them the most reliable anchor we have. Loop through each table row. Grab the part number cell, pull the link to the product detail page, separate the serial from the descriptive name. Stock cell goes through a normalizer. DigiKey mixes in-stock and marketplace inventory in the same string, plus lead time noise. We strip it down to one clean format. Price cell. Rejects out the dollar amount, ignore everything else. Run it. 3 rows. GH4001, SH40001, HFBR RUS100Z. The hard part is done. Now we need pagination. Click next page in the browser. Watch the URL. There's an S parameter now, a long encoded string that wasn't there before. That's our cursor. Drop the encoded string into an LZ string decoder. TinyJ SON object. State key 5. Page 2. Page size 25. That's the entire pagination scheme. Compressed, base 64'd, and hidden in plain sight. Now we generate the same cursor in Python. Build the dictionary, JSON dumps it with the tightest separators. Then compress with LZ string compress to encoded URI component. Attach it as the S parameter. We just reverse engineered DigiKey's pagination. From here, we can crawl every page in the catalog. One reliability detail. If the cursor overflows or the state key is wrong, DigiKey silently serves page 1 again. No error, no warning. The loop runs forever, and the CSV fills with duplicates. Compare signature of the first 5 rows against the previous page. Match means stop. Run it. Page 1, page 2, 3, 4, 5. 125 rows saved. Open the CSV, real MPNs. Normalized stock, DK colon for DigiKey inventory, MP for marketplace. Clean dollar prices. Every product URL points to a real detail page. Done. Now depth instead of breadth. Product specs aren't a fixed schema. A fiber optic cable and a microcontroller don't share columns, so we don't hardcode. Walk the product attributes table, skip the header row, omit whatever key value pairs exist. Skip empties, skip dashes, skip duplicates of the manufacturer field. This single block handles every category in DigiKey's catalog without a code change. Pricing tiers come from a separate table. Break quantity, unit price, extended price. 3 columns, append each row. Run the product scraper. Open the JSON. Fixed header at the top, MPN, manufacturer, description, datasheet URL. Pricing tiers as a list. Quantity breaks from 1 all the way to 100. And the attributes block, reflecting whatever this category exposes. Series, packaging, part status, length, core diameter, jacket material. All dynamically discovered. Same code, every category. That's the whole pipeline. Full code on GitHub. Free credits at scrape.do.